Hello everyone, today let's solve Leetcode 102 binary tree level order traversal. This is a very important tree traversal technique for coding interviews. In this traversal, we need to return the nodes of a given binary tree from left to right, level by level, which is actually the BFS or breadth first search order. This means we process all the nodes at the current level before moving to the next, and we will group the nodes at each level into their own sublist, going from left to right at each level. Say in this example, 3 is the only node at the first level, so our sublist will contain 3. We have 9 and 20 at the second level, so our second sublist will contain 9, 20. And 15 and 7 are at the third level, so our third sublist will contain 15, 7. So the final result for this example will be the combination of all these three sublists into a resultant list, which will contain 3, 9, 20 and 15, 7. Now let's see how to apply the BFS approach to get this result. Let's get familiar with two simple terms, visit and explode. Visit just means that we have seen a node for the first time, that is, we have come across it. And explore is when we visit a node and then take a look at all the nodes directly connected to it, like the neighbors in case of a graph or children in case of a tree. Why these two concepts are important is, in BFS we use a queue to keep track of unexplored nodes. That is, the nodes that we have seen but we haven't explored yet. That means we haven't looked at their left or right child yet. The queue will contain visited but unexplored nodes. So for BFS, we will first initialize a queue and add the root node 3 to it. We also set the current level to 0, as we will be going level by level. Now we will pop all the elements currently in the queue one by one and add their values to a sublist for the level. Remember, a queue is a FIFO data structure, so the node that goes in first will be the one that comes out first. Since there is only one element in the queue right now, so we pop 3 and explode it, meaning we will add its left and right child to the queue, 9 and 20, which will be processed in the next level. So as we have seen both 3 and its children, so the node 3 is explored now, and we will add it to our current sublist. Now that the 0th level is done, so we add the current sublist to the final result array, and then we increment our level to 1. Now we repeat the process. We will pop all the elements currently in the queue. So we will first pop 9 and then explore it. Since 9 does not have any child, so we don't need to add anything to the queue, and we can directly add it to the current sublist. Next we pop 20 and explore it, meaning we add its left child 15 and right child 7 to the queue. Now 20 is explored completely, so we can add 20 to the current sublist. As our first level is also over, so we move the current sublist to our resultant array and increment the level. Now we repeat the process again. We will pop all the elements currently in the queue, which are 2 elements. So first we pop 15, and since 15 has no children, so it is considered explode, and we add it to the current sublist. Now we pop 7 and it also don't have any children, so we directly add it to the current sublist as well. Now the second level is also done, so we move the current sublist to the final result array. And finally, as the queue is empty and there are no other elements left, so we return the result. In general, the time complexity of BFS in a graph is O of V plus E, where V is the number of vertices or nodes and E is the number of edges. Now, a tree is a special kind of graph, which is acyclic and has exactly n-1 edges for n nodes. So in the case of a tree, V is equal to n and E is equal to n-1. So now V plus E for a tree becomes n plus n-1 is equal to 2n-1 is equal to O of n. So this gives us the time complexity as O of n. We can also understand this in another way, where we visit each node exactly once, and for each node we enqueue it once and dequeue it once, which are both constant time operations. So the total operations are around 2n, which again simplifies to O of n. Also in BFS, the queue holds the unexplored nodes, which can be up to the maximum number of nodes at any level. In worst case, for a complete binary tree, the last level is usually the largest, containing roughly n by 2 nodes. So the space complexity is also O of n. Now let's dive into the code. First of all, we will create the result array, and now if the root does not exist, then we will directly return the empty result. Next, we will initialize our queue, for which we will be using the deck data structure from the collections, and we will initialize it with the root node. And now we will run a while loop which will run till the queue is not empty. Now within this while loop, we will create our result sublist for each level. So current level result, I am initializing it to empty. Now for all the elements currently in the queue, we will iterate through them one by one. Note that this range function will only be executed once initially before the for loop starts. So modifying the queue inside the loop does not affect how many times the loop runs. Now we will pop the elements from the deck. Node is equal to queue.popleft. So for a queue, if we are using a deck, we can use this popleft function which pops the element from the left side of the queue in constant time. Now after popping, we will explode the node. That is, if node.left exists, we will append node.left to the queue. Similarly, if node.right exists, we will append node.right to the queue. Now as we have explored the node completely, so we will add the node.value to our current sublist. And once we come out of the for loop, that means we have completed the current level, and we will append the entire sublist for the current level to our result. And once there is no more element left in the queue, we will break out of the while loop and return the result. So this was all the code for this problem. Let's run it and check. We can see that this works fine and is quite efficient. If this was helpful, hit that like button and subscribe to DKodeTree. This supports the channel a lot. Thanks for watching. See you in the next video.